Hi, this is Mick Elliott at European Microwave Week in Paris. I'm here with Ferdy Gajades, the Business Development Manager for handheld products at Anritsu EMEA. And Anritsu have brought two solutions covering 5G NR testing to Paris. Ferdy, could you first of all talk about your FR1 solution?
The FR1 solution that is typically on 3.5 gigahertz, the initial rollout at the moment in Europe. So there is a need that cellular operators have the ability to test what is coming from the base station to the user equipment, to verify this in the field. And that's why we have here a very sophisticated handheld spectrum analyzer, and it's a little bit more than a spectrum analyzer, because this analyzer can also demodulate the different antenna beams that we have with 5G. You know, grid of beams, massive MIMO, and all these buzzwords, we can do this here. So what we are seeing here is a typical time domain duplex signal of 100 megahertz wide 5G carrier. So this is the spectrum representation, and in order to go more into the details, it's very useful to switch over to the so-called real-time spectrum analyzer application. With the real-time analyzer, you see first of all the so-called location of the synchronization signaling block. If you don't know the position of the SSB, you cannot demodulate. And this is quite often today the problem. Nobody has real experience like in the good old GSM world. So once we have identified here where's the SSB, we can switch over to the so-called 5G demodulation mode. And in the 5G modulation mode on FR1, we have typically up to 8 different antenna beams on air. And what we are seeing here now is antenna beam 0 to antenna beam 7. Good. This is a signal from the signal generator, but usually in the field you would see here a pronounced peak. This is the position where you are with your UE. And then you see the neighboring channels. You see here what is the best of your beams, and if you would like to dig even deeper in, you click here one of the beams, and then you see what is the power of the pilot tones, what is the signal interference noise ratio, and so on. And using this, it is possible for an operator to get a feeling how good is the footprint in a particular cell.
Ferdy, for that description, the FR1 solution, perhaps now you'd like to talk us through what Anritsu can offer at the 28 gigahertz frequency.
So-called FR2. Typically, this will happen between 26 and 28 here in Europe. We have here, for the purpose of the demo today, a real 28 gigahertz signal that is coming from a base station simulator. And the big difference between FR1 and FR2 is, on FR1 we had 8 antenna beams, on an FR2 we may have up to 64 individual beams that are pointing to user equipment. And the scope of work is here exactly the same. You're going here into the 5G analyzer mode, you're getting the same information, but now you see not only 8 beams, you can scroll here through up to 64 beams. And in our particular case here we have 31 antenna beams coming from this base station simulator. Finally, the result is the same, but the big difference is on 28 gigahertz, the cell itself, or the reach out of the signal, is much more limited compared to 3.5 gigahertz. Thank you.
Thank you very much. Hi, this is Mick Elliott of Electronic Specifier at European Microwave Week. I'm here with Paul Holds, Field Application Engineer for Anritsu. And Paul is going to describe some of the features of Anritsu's latest vector network analyzer.
Yes, so today what we have is the VectorStar VNA. This is the latest evolution of the VectorStar family. So this one is actually on wafer for device characterization, goes all the way up to 220 gigs. So the main interface uses a 0.6 millimeter connector. So with the VNA, VectorStar VNA, the concept of this is you can start off with a base VNA and then build up as your needs progress from 2-port or 4-port, going all the way up to broadband. So we start from 70 kilohertz and go all the way up to 220 gigs. We have other flavors in 110 and 145 also. But it allows you to develop as your needs and your device is growing, the frequency range is required. we just add capability towards this.
Clearly got a demonstration here. Can you just talk us through what you've been showing visitors to the show?
So basically this is an MPI probe station, and here we have a direct connect. So the advantage of this miniaturized modules is that we can go directly onto the wafer bed with these probes, so that we minimize the loss that you would have via some coaxial interface from the probe tip down to the wafer bed. So and just we've stayed on the new MPI probe station here with some specific patterns that are designed for our Anritsu modules. What these miniaturized modules allows us to do is it allows us to use a perhaps smaller wafer probing station, because we can fit them quite easily on these dedicated platens.
Okay. Paul, thank you very much for that. Appreciate it. Thank you.